It started as a background problem. At first, astronomers thought it was noise, a discrepancy so small it barely registered. The universe, according to every model, should look roughly the same in every direction. Same temperature, same density, same structure, on average. That assumption wasn't philosophical, it was foundational. So when measurements didn't line up perfectly, scientists shrugged. Instruments drift, calibration slips, human error exists. Except the error didn't go away. The measurement that refused to agree. Two different methods were used to measure how fast the universe is expanding. One measured nearby galaxies directly. The other measured ancient radiation from the early universe. Both methods were precise, repeatable, independent, and they did not match. Not by a little, by enough to matter. This wasn't a rounding issue. It was a contradiction baked into reality. Why this is a problem? If both measurements are correct, and all evidence says they are, then something fundamental is missing from our understanding of the universe. Not a small correction, not an unknown variable, something entirely unaccounted for, a force, a property, a behavior of space-time itself. The equations don't balance, and the universe doesn't care. The unsettling implication. This means the universe has changed its behavior over time in a way we cannot explain. Not slowly, not smoothly, but abruptly enough to break our models. It suggests the rules governing reality may not be fixed. They may evolve. Why that's disturbing? Physics depends on consistency, the idea that yesterday's universe and today's universe obey the same laws. But this measurement suggests the universe may have different rules depending on when you observe it, not different conditions, different rules. We can measure the disagreement perfectly. That's the worst part. The uncertainty is shrinking. The data is cleaner than ever. Every improvement makes the contradiction sharper. There is no sign it's going away. This isn't just about space. If the expansion of the universe behaves differently at different epochs, then constants may not be constant. Forces may emerge or vanish. Reality itself may be context-dependent. We are not discovering what the universe is. We are discovering that we misunderstood how stable it is. The psychological shock. This discovery didn't arrive with explosions or dramatic signals. It arrived quietly, in spreadsheets, in error bars, in peer-reviewed papers that end with the same sentence phrased politely. This result is currently unexplained. That sentence hides panic. Because unexplained doesn't mean mysterious, it means incompatible. Why scientists don't talk about it casually? Because fixing it requires breaking something else. Dark energy might not behave as expected. Gravity may not work the same everywhere. Our picture of the early universe may be incomplete or wrong. There is no clean fix, only trade-offs. The deeper fear. If the universe's behavior can change without warning, then predictability is temporary. The rules that allow stars, planets, and life to exist might not be permanent. They might just be what's happening right now. Measurement without comfort. We've always believed that better instruments would bring clarity. This measurement brought precision without reassurance, accuracy without understanding, knowledge without safety. Why this may be the most disturbing measurement ever. Not because it threatens Earth, not because it suggests aliens, not because it implies destruction, but because it tells us something far worse. Reality is not obligated to remain consistent, and we only know that because we measured it.